Alright, chapter 4.3 gets into one of our favorite words, which is factoring. Very important message for those of you who have not been working to finish every day. For those of you who have been working to finish every day, thank you for that. You're doing your best to keep this classroom running smoothly. But those who do not, if you don't work to finish this ASAP, you're probably going to have a difficult day tomorrow and potentially a very bad week, because things are going to start moving really strongly this week. Factoring is one of the most intimidating processes in algebra. It causes students to immediately freeze up, lose all sense of fundamental steps. If you trust the notes and practice like you should, factoring is actually one of the easiest things to do once you know how to do it. So I'm breaking this down into four sections, 4 steps. The first step is to translate the expression. So the first step to factoring is translating the expression. There are actually homework questions that allow you to do this. First off, you have to convert it into what I call a combination of values, because in just the form you really can't do anything with it, but once we turn it into something to work with, everything gets better. So in the expression ax squared plus bx plus c, the combination is that you are looking for numbers that multiply to equal a times c and add to equal b. So I always just kind of write this little rainbow whenever I do it. So multiplies to equal that and adds to equal whatever is there, including the sign, that is. So just keep that in mind. In other words, your combination multiplies to be the outside coefficients and adds to make the middle coefficient. So again, on your notes, it will help if you kind of do it the way I'm doing it, but put a dot equals and then simply take this to that, which is negative 12, because that's 4 times negative 3, and then adds to be negative 9. That is the combination that's going to open this problem up. Kind of like I said key before earlier, but this, what I would call a combination, means it opens the problem for you to go ahead and get to work. B is tricky, and that's, I have to do this so you understand. Notice that there is no x term, which means that this is your outside term, so this multiplies to be negative 55. And because there's nothing in the middle, no b term, it means that it's 0. This one here, again, you want to be careful because this multiplies to make negative 12, because that's 1 times negative 12, and adds to make 1. Please don't ever put that it makes x, because again, the moment you don't have any, the moment you get rid of all your letters and variables is when you can actually work the problem out. So again, that's a 1 there times negative 12, and that's a 1 there also for you to go through. So again, this is best learned through practicing and questioning your mistakes, so just be sure to use your notes when you begin. And again, ask me as many questions as you need to. I'm trying to get through this these notes as fast as I possibly can without rushing, so you have a lot of time to ask questions. You do not learn how to factor by watching someone else factor, or just by taking notes. You actually have to get into it. So after you have a combination, you now have to develop a skill of finding the value. So since we're in Algebra 2, I'm going to jump straight to the practice, because again, your skill set is higher, which means I can do this. What I would do is take the number that multiplies to make and put the 270, and again, in the hard problems, I would just make what we call a factor tree. And so the way you make a factor tree, or it's not really a factor tree, but what I call a factor tree, is you start with 1 and you keep putting numbers that multiply until you get something that is equal or higher in your calculator. So for example, 1 times 270 would be 270. 2 times 135 is 270. That's if you divide by 2. 3 times that, I think it's 90. I don't know if 4 goes in there. I don't think it does. Nope. 270 divided by 5 is 54. 270 divided by 6 is 45. 270 divided by 7. Nope. 270 divided by 8. And it seems like it can take forever, but it really doesn't, because as you notice, my numbers are getting closer. 9 and 30. 10, I believe, is 27. 270 divided by 11, I don't think goes. 270 divided by 12. No. 270 divided by 13. And again, this is where the work is, but you won't always get numbers this big. But again, notice how my answer, I'm sorry, it's in the part here, but notice how my answer is getting closer to the number I'm dividing by. And that's really what you're looking for. 270 divided by 15 is 18. 270 divided by 16. Notice that my answer says 16, which means my next answer, 270 divided by 17, Notice how this answer is smaller. What that means is that the number I'm checking is on the big side. So we blatantly make this a small side versus big side list, and here's where you have to use your head. Alright, if it multiplies to make 270 or negative 270, that means the signs are different. You might want to write this and make sure you remember it. If it adds to make negative 3, that means your big numbers are negative, which means that these have to be positive, and the ones that make 3 are 15 and negative 18. So again, you won't always get numbers this big, but since it is notes, I want to show you the hardest situation you're going to see. If you can think of the numbers without making this big tree, that's fine. Sometimes you can. For example, if I said I want numbers that multiply to be 10 and add to make 7, obviously you know those numbers are 5 and 2. So feel free to use your head, but again, in the tough situation where you get a big number, which you never know if that'll happen or not, just make sure you have a system, which is what we're doing here. 176, 1 times 176, 2 times, I believe, 88. Let me make sure. Yeah, 176 divided by 3. Nope. 4. Yep. 5, no, because it would end in a 5 or 0. 6, nope. 7, 8, 22, 9, 10, it would end in a 0. 11, yep, 11, 16. But again, notice how my answer is getting closer, and that is how you know you're starting to wrap it up. So pay attention to, it's kind of like when you're driving or doing something important like that. Make sure you're looking at the road and looking at where this is going. They're now the same, which means there's really no need for me to check 14, but I'll do it just to show you that this is now smaller, which means this is my closed set of numbers. And once again, this is where you have to think. If it multiplies to make a positive 176, it means the signs have to be the same. This means that my big numbers are negative, and if the signs are the same, then that side should be negative as well, and the ones that add to make negative 27 are negative 11 and negative 16. So again, even if I type that in, negative 11 times negative 16 should give me 176, and negative 11 plus negative 16 should give me negative 27. That's what you're looking for, is the combination, or solving the combination is the numbers that make that happen. Here we have 324, which we could make a list here, but let's think for a second. Anytime it equals 0, that's a special case. If it equals 0, that means that they add to make 0. So you're pretty much looking for, first off, the signs are different, and it only works if the signs are different. But if it adds to make 0, you're looking for the same number that's added and subtracted from itself. So think for a second, how do you find a number that multiplies by itself to make 324? You find it by doing the square root, which is second x squared, 324, and 18 and negative 18 have to be your numbers. Again, you can check that out. 18 times negative 18 is negative 324, and of course 18 plus negative 18 is 0. So again, you won't see numbers this big all the time, but you need to make sure you're ready for them as you go. After that, it gets kind of easy. The hardest part is really finding the numbers, especially if they give you big numbers like that. But once you've found the x values, you've created two numbers that are equivalent to the value of b in the original expression. Therefore, it's legal to substitute the two values for the original value of b. Work out the following examples with me. Again, pay attention to the fact that our new expression has not changed because it still has the same amount of still has the same value. Expanding expression, the combination has been solved for you. So this here, and you don't need to write this, but just carefully look. You're looking for numbers that multiply to be negative 48 and add to be negative 13. Alright, I did the numbers for you, but just to show you that I did the numbers for you and understand what those numbers mean, 3 times negative 16 is your negative 48. 3 plus negative 16 is your negative 13. So again, the numbers that I'm giving you are here. So what you do is you simply rewrite the first term, and then take these two numbers plus 3p minus 16p minus 12. leave the first, leave the third, but you are splitting this into a positive 3 and a negative 16. But again, pay attention to the fact that if I put 3 minus 16 together, it's still negative 13p. Alright, so splitting is easy. The hard part is getting the numbers. This one here, if you had the issue, or you had this question, you rewrite the first one, 9m squared plus 21m minus 21m minus 49. Again, just keep the first, keep the third. So use these two to pretty much just put them in the middle, and that's all you have to do. Again, this one, you'd be looking for numbers that multiply to be 36 and add to be negative 15, which should actually be negative 3 and negative 12. Sorry about that. Put those signs on there. And that would be x squared, because you bring down the first, and then you bring down your number with a variable, and then you bring down your other number with a variable, and then you bring down your third number, or last number. And again, notice your x squared is going to stay x squared, 36 stays 36, negative 3 and negative 12 make negative 15. That is your splitting part. Alright, or sorry, expanding part in terms of getting what's going on. And now that we've expanded the trinomial into 4 parts, we can separate into 2 groups and factor the GCF out of both of them. This typically leads to an answer that could be simplified further. The explanation sounds much more intimidating than the actual process, but before we get to that, let's look at some basic skills you might need. GCF, again, I'm giving you worst case scenario here. If you're looking for the GCF of 2 big numbers, there's a lot of different ways to do it, but you've got to keep in mind that there has to be a better way to do it, and there always has to be a best way to do it. And although I don't think I've identified the best way, I have identified at least a faster way. And that way is by using the fact that your calculator reduces fractions. For example, think about this. If I put the fraction 10 over 20 into a fraction calculator, then what it does is it turns it into 1/2. What did I just divide both of these numbers by? Obviously, I divided both numbers by 10. Again, you don't need to write this, but I'm just showing you something. This is your GCF. And any calculator that reduces fractions, which all calculators reduce fractions, actually give you the GCF. You just have to do top divided by top, which is 10 divided by 1 is 10, or 20 divided by 2 is 10. So again, the theory I'm using here is that if my calculator can reduce a fraction, then it'll actually tell me what the biggest number that goes into those numbers is. So what I would do is I would take 289 and 323 and I would reduce them. Now pay attention, because here's another calculator trick you're going to learn. So 289 divided by 323 equals, of course, you get a decimal. If you hit the math button, you'll see a conversion arrow that says, sorry, it's not on the screen, conversion arrow that says arrow frac. Hit enter, and then hit enter again, and you'll see that it turns into 17 over 19. And again, all you have to do is either 289 divided by 17 or 323 divided by 19. But even in your calculators, the way I would do it is I would just take the first number that I used divided by the first number that came out and see that my GCF is 17. But just to prove it, if I were to do the 323 divided by 19, I still get the GCF of 17. Again, that is the number that was missing from that. So if you're ever in a problem where you have big numbers and you have to find the GCF, just put the numbers into a fraction and then reduce that or figure out what the number is by dividing the 2 top numbers or the 2 bottom numbers. Again, if you're going to find the GCF of these two, you don't need to type in or write the fraction, because you can actually do this without writing the fraction. But for the sake of your notes, I suggest you do this. But 783 over 459, 783 over 459 equals, and then the general phrase is math enter enter. So math enter enter turns into 29 over 17, and then again just take first number divided by first number and get the answer of 27. So with that said, GCF factoring is where I now look at the numbers and say, what's the biggest number for 48 and 56? If you know it already, just say it, or just write it. But the thing here is, you don't really need it for 48 and 56. I believe the number is 8, and if you're unsure, all you have to do is go 48 divided by 56 equals math enter enter, and then 48 divided by 6 is 8, so you know it's 8. So the biggest number I can take out is 8. But here's where you have to be careful. It's what you learned in Algebra 1. This has 2 x's, that has 1. They have 1 x in common. 48 divided by 8 turns into a 6. 2 x's taking 1 off turns into x. Copy or minus. 56 divided by 8 is 7. And my x is gone. That is how you factor out the GCF. This is a very important thing because without factoring out the GCF, you really can't do the last part of what we're going to do. And so make sure you understand that part. Factor out the GCF of 39x plus 91. Well, the thing is, if you don't know what 39 and 91 is, do 39 over 91 equals math, enter, enter. 39 divided by 3, I believe, is 13. That means that my biggest number I can take out is 13. Here's where you have to be careful on this one and the one from before. If both of these have an x, you can take off an x. But notice, both of these terms do not have an x. 91 doesn't have it, so that's all I can take off from both. I then get 3x plus, I believe your fraction even tells you that it's going to be 7, which is what you have. And again, if you were to distribute that, 13 times 3, 39, 13 times 7, 91. After you do that, you're going to end up with something that looks like this. Again, these are all basic skills things, so make sure you keep these notes and look at them whenever you're stuck on something, because here's what's easy about it. Factor means take off what they have in common. Both of these have a 3x plus 1, which means I'm going to take off 3x plus 1. And when you look at what's left over, if I took this 3x plus 1 off, I am left with 7x. And if I took this 3x plus 1 off, I'm left with plus 5. That is how you wrap up your factor. Alright, so again, you don't see the whole picture yet, but just make sure you understand each of the things I did. Make sure you know how to factor out the GCF, or find the GCF. Make sure you know how to factor out the GCF, and then understand that you need to also know this step here, where you're simply saying both of these have a 5x plus 3, so I'm going to take off 5x plus 3, and then I'm going to be left with x minus 2. So take off whatever it has in common, and then the other parentheses is going to have whatever was on the outside. Alright, so the problem we're looking at here, just so you know, is one that has been found and looks just like expand the x term. Where I found the numbers, did the combination, found the numbers, and split it, because now you have 4 terms. So what you're going to do when you have 4 terms is you are going to separate it in front of the sign, not after the sign, but separate it in front of the sign and factor each one. So ignoring this part, the biggest thing I can take out of 6 and 21 is 3 and a d. 6 divided by 3, 2. There's a d left over. 21 divided by 3, 7, with nothing left over. Copy the sign. Always copy the sign. That's why we do it in front of the sign, because this sign is always going to be the same as that sign there. And then look at these two, 8 and 28. The biggest number I can take out is 4. And you should end up with the same thing. Honestly, whenever I do it, I just copy it over, and you'll see why in just a second. But just to be sure, 8 divided by 4, 2. There's a d left over, plus, and then 7, which means now we do what we did up here, which is we take off what they have in common, 2d plus 7, and we're left with 3d plus 4. That is your part that you're looking at. And look at this. 2d times 3d makes 6d squared. 2d times 4 makes 8d. 7d times 3d makes 21d. 7 times 4 makes 28. So really, you just kind of put them all into a nice packaged form. One more. Split in front of the sign. Again, 27 and 36, I think the biggest number you can take out is 9, and both of these have a x on it. 27 divided by 9 is 3. Had 2 x's, took 1 off, you're left with 1. Minus 36 divided by 9 is 4, with no x left over. Please make sure you copy the sign. And again, if I were you, I would do it the grown way, which is, as long as you know you factored this right, that is definitely going to be in the second part, because if it's not in the second part, we can't do our job. But here's the thing, 3 and 4, nothing comes out of. You need to make sure you put a 1 there, because if you remember, there has to be 2 outside numbers. So when you don't have anything coming out of it, just go ahead and put your 1, and then you end up with 3x minus 4 times 9x minus 1 as your part. Again, checking. 3 times 9, 27x squared. 3 times negative 1, negative 3x. 9 times negative 4, negative 36, negative 4 times negative 1, positive 4, just to show you that copying that did actually work like it's supposed to. So today's work is about learning how to factor, but we haven't even gotten into the material for this section. Tomorrow's where we will actually solve by factoring. That's why it's important you get a decent idea of how factoring works tomorrow or before tomorrow. I'm not going to teach you as if you know how to factor tomorrow, but I will teach you as if you experienced it, which means I will not be slowing down and going over all the stuff. You need to make sure you know how to create your combination, how to solve the combination, how to split the middle number, and how to do the part that we just did. And just to wrap it up, I am going to give you one question. So let's see, 3x squared, I've been making these up for years, 8, that makes 24, 2x. So if I was going to factor this, again, all 4 steps that we just did, first thing we want to do is make the combination. So 3 times negative 8 is multiplies or equal negative 24, adds to make 2. Quickly, again, these numbers are easy enough. Those are 4 and 6 with a, this means the signs are different with a positive big number. Again, as you get better at this, just please make sure you're looking at the fact that I'm just going through the process. I created the combination. This solves the combination because negative 4 times 6 is negative 24. 6 plus negative 4 is 2. I am now going to split this middle term, 3x squared minus 4x plus 6x minus 8. You then separate it down the middle. Take off what you can. I cannot take anything off of 3 and 4, but I can take off an x, and I'm left with 3x minus 4. Copy the sign always. 6 and 8, pull off a 2, and of course you're left with 3x minus 4, which then gives you 3x minus 4 and x plus 2. This is your factor. But just to prove it, 3x times x, 3x squared, 3x times 2, 6x, negative 4 times x, negative 4x, negative 4 times 2, negative 8, and we obviously know that this leads back up to that anyway. Alright, so again, get your practice. Please use this time wisely. Get as much as you can. The homework is separated into sections and then it gets into factoring, but make sure you practice your sections, and please make sure you ask for assistance as soon as you don't know what's going on. We are working for fluency here, not just getting it done. You need to be fluent. So please feel free to hit a similar question so you can keep practicing doing the process that you're weak at. Other than that, good luck.